Finite math. In this video, we're going to talk about mathematics of finance. Specifically, we're going to find the future value of an ordinary annuity when we know the payment, and then the sinking fund when we need to find the payment. And this is the formula we're going to be using. As you go through the video, you're going to notice some icons on the left. When you see this icon, we're talking about the process. We're going to do examples, you're going to practice, there's going to be a self-quiz, and finally, what you need to do to get good at it. Remember, it's not magic, it's math. I'm also going to be using www.symbolab.com for our calculations. Let's get started. Definition of annuity. Let's say you want to save money to go on a vacation, or you want to save money now for your baby's college education. A strategy for saving a little bit of money in the present and having a big payoff in the future is called an annuity. An annuity is an account in which equal regular payments are made. There are two basic questions with annuities. How much money will accumulate over time given that equal payments are made? What periodic payments will be necessary to obtain a specific amount in a given time period? Now, periodic means how often you will need to make a payment. It could be monthly, yearly, and so on. Future value of an ordinary annuity. One formula is based on payments made at the end of the payment period. This is called an ordinary annuity. The annuity due is when payments are made at the beginning of the payment period. For this video, we're going to be doing an ordinary annuity. Future value of an ordinary annuity. The general formula for a future value of an ordinary annuity. Now, this is what you're going to see in your textbooks, where FE is the future value or amount you want in the end, PMT is the periodic payment, I is the rate per period, and I is always rate over M, where N is the number of payments per period, and that would be M times T, where M is the number of compounding periods in 1 year, and T is the total number of years. Payments are made at the end of each period. I want to point out that for this video, we're going to be using this formula. It's exactly the same as the other formula. Instead of writing I, we're going to write R over M, because that's what I is. And then for N, we're going to do M times T, because that's what N is. So why make our lives harder? We're just going to put all the letters into the formula right away. Find I, the rate per period, and N, the number of periods for the following annuity. Monthly deposits of $340 are made for 7 years into an annuity that pays 8% compounded monthly. Round your answer to 4 decimal places as needed. For these first couple, we have to find I and N. Remember, the I, rate of the period, is the rate over the number of deposits. So R for this one is 0.08. We always have to change the percent to a decimal. And how many times does it compound? Monthly, so that's 12. We get 0.00666, but we have to change it to a percent. First, let's round to 4 decimal places, and then convert it to a percent. We need to find N, the number of payments per period. Well, that's M times T. M is 12 because it's monthly. And how many years? T, that's 7. So the number of payment periods is 84. Suppose a $1,000 payment is made at the end of each quarter, and the money in the account is compounded quarterly at 6.5% interest for 15 years. How much is in the account after the 15-year period? This is our formula. Now let's fill in what we know. We know that the payment is $1,000 because they tell us that. What is our rate? Well, 6.5%. We need to change that to a decimal. Now everywhere there's an R, we're going to put in our percent. M is the number of times it compounds. And for this one, it compounds quarterly. So we're going to put a 4 in for our M's. Finally, what is the time? The time is 15 years. So we're going to put a 15 in for our T. Now I mentioned we're going to be using Symbolab.com to put in our formula. So let's go there. Here we are. We're going to put in this formula. We're going to type in, enter a problem. So we're going to do parentheses, and our parentheses is right here, 1,000. Over arrow on your keyboard. Next, we have a fraction. On the top, we have another parentheses, and you're going to notice that I'm following exactly what I see. 1 plus, we have a fraction. In the numerator, 0.065, and the denominator, 4. I'm going to over arrow. The exponent, right here, is 4 times 15. So I'm going to type 4 times 15. I'm going to over arrow, and then minus 1. I'm going to click in the denominator. In the denominator, we have a fraction. So I'm going to type fraction, 0.065 over 4, and we're going to hit go. And here is our answer. So here we have it. Let's go back to the PowerPoint. We have $100,336.67614. We need it as money. We're going to round to 2 decimal places. So our answer is $100,336.68. Let's continue from the last example. How much interest was earned over the 15-year period? Payments over 15 years. We're going to take the 1,000 per month times 4, because we're doing it 4 times a year, times 15, because we have 15 years. So the amount that we invested is $60,000. Our future value is $100,336.68. Therefore, the amount of accrued interest is $100,336.68, what we have in the end, minus what we invested, which is $60,000. How much interest was accrued? That would be $40,336.68. All right, you get to do this one by yourself. The Bank of Catherine, that's me, well, the Bank of Catherine offered an annuity that pays 4.5% compounded monthly. If $1,146 is deposited into this annuity every month, how much is in the account after 6 years? How much of this is interest? Round your answer to the nearest dollar. Okay, pause the video, do it, and then press play to see how you did. We're going to be using this formula, so let's fill in what we know. We know that our payment is $1,146. Our interest is 4.5%, but we have to convert that to a decimal. How many times is it compounded? Well, it's compounded monthly, so we're going to put 12 in for our M's. And then finally, how many years? 6. All right, let's go to Symbolab to work this one together. We're going to put in 1,146, then a fraction. In the numerator, we're going to have a parentheses first, 1 plus, and a fraction, 0.045 over 12. Over arrow on your keyboard. The exponent is 12 times 6 over arrow minus 1. Let's go to the denominator. We have a fraction, 0.045 over 12. So let's go. All right, write this number down because this is going to help us find the answer. We figured out that the future value is $94,523.0278. Since we're talking money and they ask us to round to the nearest dollar, our answer is $94,523. That means the amount in the account after 6 years is $94,523. How much interest is accrued, or how much of this is interest? We're going to take our monthly payment, $1,146, times 12, because it's monthly, times 6, that's the number of years. So we invested $82,512. We take our future value minus what we invested, and that gives us our interest. The amount of interest accrued after 6 years is $12,011. You get to try this one also. Use the future value formula to find the indicated value. Round your answer to the nearest cent. Pause the video, do it, use Symbolab, and then press play for us to work it together. Now this one, I told you to look at the letters. You're going to notice they give us N and I. So for this one, we're actually going to be using the other formula, the original one. So let's fill in what we know. We know the payment is $109. The interest is 0.04. The N is 20, but we have to find the future value. Let's put this in Symbolab. We have $109, and then parentheses, fraction. Now in the top, you're going to notice we have another parenthesis. So I'm going to put another parenthesis in there. That is 1 plus 0.04. Over arrow, we have an exponent of 20. So I'm going to do my exponent 20 over arrow minus 1. All over, now I'm in the denominator, 0.04. And let's go. All right, we need to write this number down. Now let's go back to our question. The future value is 3,245.81056. The question asks us to the nearest cent. So that means our future value will be $3,245.81. The amount in the account after 20 years is $3,245.81. The sinking fund. A sinking fund is when we know the future value of the annuity and we wish to compute the monthly payment. Here's the ordinary annuity. When we want the future value but we have the payment. Here is the formula we're going to use when we want to find the payment but we're given the future value. Now this is the original formula. Remember, I like to convert everything because I is R over M. And N is M times T. So we might as well just put all the letters in right away instead of having to think, oh my gosh, what's I? Oh my gosh, what's N? So that's the formula we're going to use. Let's do some examples. Suppose you decide to use a sinking fund to save $10,000 for a car. If you plan to make 60 monthly payments, 5 years, and you receive 12% annual interest, what is the required payment for an ordinary annuity? Well, here is our formula, and let's fill in what we know. Well, we know we want $10,000 for our car. The annual interest rate is 12%, so we're going to convert that to a decimal. The number of monthly payments, well, that's monthly, so it's 12. We're going to put 12 in for all of our M's. And then finally, what is the time? Well, the time is 5 years. So this is the formula we're going to use. Let's go over to Symbolab and plug it in to see what our payment needs to be. Okay, so we're talking about $10,000 we want for our new car. I'm going to do parentheses. We're going to have a fraction. Now in the top of our fraction is another fraction. So it's going to be 0.12 over 12. In the denominator, we need another parentheses because we're going to have 1 plus a fraction, 0.12, down arrow 12, over arrow. Our exponent is 12 times 5, over arrow minus 1, and let's go. Okay, you need to write this number down. And let's go back to the question. So the payment is $122.44444. The thing is we want to talk about money. So our payment is going to be $122.45. You'll need to deposit $122.45 into your annuity to purchase your car after 5 years. Okay, you get to try this one by yourself. A company estimates that it will need 59,007 years to replace a computer. If it establishes a sinking fund by making fixed monthly payments into an account paying 6.6% compounded monthly, how much should each payment be? Pause the video, do this one, and then press play for us to work it together. Remember, I'm going to be using Symbolab to do our calculations. Let's work this one together. We're going to first fill in what we know. Well, the company needs $59,000 in the future. They're paying 6.6% interest, so we're going to put our interest as a decimal into the formula. It's compounded monthly, so our M is going to be 12, and finally, they want to do this in 7 years. Let's go to Symbolab to calculate. First, let's put $59,000 in there. Then we have a fraction. In the top of the fraction, we have another fraction, 0.066 over 12. I'm going to go down arrow into the denominator. The first thing I'm going to do is parentheses, 1 plus another fraction, 0.066 over 12. Over arrow on the keyboard, we have an exponent, 12 times 7, then over arrow minus 1. And let's go. All right, you need to write this number down. And let's go back to our equation. We end up with 554.47589. The question asks us to round to the nearest cent. So that gives us $544.48. The company will need to deposit $544.48 into an annuity to replace their computers in 7 years. Here's another one for you to try. Pause the video, do it. I'm going to use Symbolab to calculate, and then press play to check. This one asks us to use the future value formula to find the indicated value. For this one, we need to find the payment. So this is the formula we're going to use. How do I know that it's the original formula? Let's look at what they're giving us. They're giving us a future value, they're giving us N, and they're giving us I. They're not saying monthly, they're not saying a percent, anything like that. So I know I have to use the original formula. Let's fill in what we know. The future value that we want is $3,470. The interest is 0.07, and then N is 8. Let's go to Symbolab and calculate. All right, we're going to put $3,470 and then a parentheses with a fraction. 0.07 is in the numerator or the top. Then we're going to have another parentheses, 1 plus 0.07 over arrow. The exponent is 8, and then over arrow minus 1, and go. Okay, we need to write this number down. Now let's look back at our formula. We ended up with 338.21313. They ask us to round to the nearest cent. So this gives us $338.21. We'll need to deposit $338.21 into an annuity for 8 years to earn $3,470. Here's our self-quiz. You're going to pause the video, complete the questions, and then press play to check. The whole point of the self-quiz is to see what you can do without looking back at your notes. If you have to look back at your notes, that's what you need to practice. As we go through the problems, anything that you get wrong, that's also what you need to practice. All right, pause the video, do these, and then press play to check. Let's do A first. Use the future value formula to find the indicated value. Round your answer to the nearest cent. For this one, they're giving us the future value N and I. Hopefully, you picked the correct formula. Let's fill in what we know. We know that the future value is $3,851. Our interest is 0.07 and our N is 11. Let's go to Symbolab to do the calculations. First, we're going to enter 3,851. Then we have a fraction. In the numerator, we have 0.07. In the denominator, we're going to put a parentheses, 1 plus 0.07. Over arrow, we're going to have an exponent, which is 11. Over arrow, minus 1. And let's go. All right, write down this number. We're going to need it for our answer. Let's go back to our formula. We ended up with 243.98744. The question asks us to round the answer to the nearest cent. So that will give us a payment of $243.99. Let's look at B. Recently, the Bank of Catherine, that's me, offered an annuity that pays 6.6% compounded monthly. No, I don't have a bank. If $2,307 is deposited into this annuity every month, how much is in the account after 7 years? How much of this is interest? Round your answers to the nearest dollar. Here's the formula we're going to be using. Here's the formula we're going to use. It's because we need to find the future value. Let's fill in what we know. Our payment is $2,307. Our rate as a decimal is 0.66. It's every month, so M is going to be 12. And finally, we're going to do it for 7 years. Let's go to Symbolab to calculate. All right, our payment is $2,307. We now have a fraction. In the numerator, we need a parentheses, so we're going to do 1 plus, and another fraction, 0.066 over 12. Over arrow, the exponent is 12 times 7. Over arrow, minus 1. Let's go to the denominator, and the denominator is a fraction, 0.066 over 12. And let's go. We need to write this number down. Let's look back at our formula. We ended up with 245,480.46371. Now the question asks us to answer to the nearest dollar. So this gives us $245,480. How much interest is accrued? Well, first, we need to figure out how much we put in. So $2,307 times 12 months times 7 years, $193,788. That's how much we invested. We're going to take our future value minus how much we invested. That means the interest accrued is $51,692. Okay, well, what do you need to do to get good at this? Hello, you need to practice. And even if your homework doesn't count towards your grade, you still need to do it because the only way you're going to get good at it is practicing. Did you like this video? Why not like it? Did you really like it? Why not subscribe? Did it help you? Why don't you share it with a friend? Remember, it's not magic, it's math.